Okay, let's look at Newton's law of cooling. All right. So the differential equation is d capital T over dt is equal to negative k times quantity capital T minus capital T sub s. So T sub s, capital T sub s is just the temperature of the surrounding, which is kept constant. All right. The initial condition is, let's see, f of t is equal, t of 0 is equal to t0. All right, this is another example of a separable equation. So let's use the same technique to solve that. All right, so we can solve this by first divide through by capital T minus capital T sub s. All right, then you will get the 1 over T minus T sub s d capital T over dt, which is equal to just negative k, right? Then we can take the integral of both sides with respect to t, integral here with respect to t, right? Then we can cancel dt on top and dt on the bottom, right? Then antiderivative 1 over t minus t sub s with respect to t would be simply natural log of absolute value of capital T minus capital T sub s, right? This is equal to antiderivative of negative k is negative k t plus some constant. I'm going to call it the C1. Right? And first we can just rewrite it in terms of exponential function. So raise e to both sides of the equation. You will get the absolute value of t minus t sub s is equal to e to the negative kt plus c1, right? But I'm going to rewrite it as e to the c1 first, multiply by e to the negative kt. All right, then we need to get rid of this absolute value sign, so we can just consider positive 1 and negative 1. So it's going to be t minus t sub s is equal to, right, it's going to be a plus or minus e to the c1 times e to the negative kt. Right? So since this constant right here is fairly complicated, I'm going to call this guy c. Right? So this is going to be just a c times some constant e to the negative kt. Right? Let's find the constant here. So we're going to use this initial condition. So plug in 0. So if say t equals 0, we know that t of 0 is t0 minus t sub s is equal to c times e to the 0. So it's going to be just c, right? So we found c to be t0 minus ts. So therefore, we'll get the equation. So t minus ts is equal to c is t0 minus ts. Then you have e to the negative kt, right? So therefore, we have this temperature function t. We can just move this guy over to the other side. So this is going to become t sub s plus quantity t0 minus t sub s times e to the negative kt. Right? So this is a solution of this initial value problem. All right, so let's apply this to a more concrete problem. So let's look at the corn dog problem. Right? let's say you are in a cold ice rink. The temperature is kept at the 10 degrees Celsius, and the corn dog initially is 60 degrees. And it says that it cools down to 40 degrees in 30 minutes, right? Then question is when this the question is when the temperature of the corn dog becomes, say, 20 degrees, right? So let's do that, right? So first we have to come up with a different equation. So we already solved this. So temperature of the corn dog is going to be, I'm going to write it as a T of T is equal to, right? Temperature of the surrounding in this case is 10. So it's a 10 plus T0 minus TS. So T0 is 60 minus TS is 10. So it's going to be 60 minus 10 is 50. Right, e to the negative KT. So this is probably the best we can do so far. But the initial condition is if T after 30 minutes, so T is in minutes, then you will get, let's say, 10 plus 50 e to the negative K times 30 is equal to, cools down to 40 degrees. So this is equal to 40, right? So we can get some information from there. I'm going to go down here, right? I'm going to say subtract 10 from both sides. So you will get the 50 e to the negative K times 30 is equal to 30, right? Then divide it through by 50, then you will get e to the negative K times 30 is equal to 30 divided by 50 is 3/5, right? Then I'm going to just simply raise this to 1 over 30th power, so I can get rid of this 30. So you have e to the negative K is equal to, right, 3/5, raise it to the 1 over 30th power. All right, so we know the complete formula for the temperature equation. So therefore, so this will give us temperature function T of T is equal to, right, 10 plus 50, right? Now we found e to the negative K to be 3/5, 3/5, raise it to the 1 over 30th power, so 1 over 30th power. Then you have a T here, so I'm going to have to put T, right? So this is the complete function, right? So we want to know the time when this becomes 20 right here. So we're going to set this guy equal to 20, right? Then we can just solve this equation. So I'm going to subtract 10 from both sides. So you have a 50 times 3/5 to the T over 30th power is equal to, let's see, 20 minus 10 is going to be 10. All right, then I'm going to divide through by 50. So you get 3/5 T over 30 is equal to 10 over 50 is 1/5. Right, then I'm going to go ahead and apply natural log to both sides. So natural log there. Right, this way we have, right, we can put the T over 30 in front. You have a natural log of 3/5 is equal to natural log of 1/5. So I'm using the log property to bring this guy right in front, which is this guy right here. All right, then we can find T. by simply, right, we have to multiply by 30, and to get rid of that, and divide by natural log of 3/5, right? So t is going to be equal to, right, so multiply by 30, natural log of 1/5, so that's original right hand side, and divide by natural log of 3/5, right? And if you punch into the calculator, this guy comes out to be 94.5 something, so I'm going to just say 95, about 95 minutes, right? So that's the answer we're looking for. So the answer is, in about the 95 minutes, the temperature of the corn dog goes down to 20 degrees Celsius. All right, that's it. I hope that this was clear.